All right, so this is topic 5, and it's on force, acceleration, and work. There's a video here that I will post on the Google Classroom, and this sort of goes over Newton's laws with Crash Course, which is a good type of video to watch when you're trying to understand different topics in like really anything, especially science. All right, so it says force and motion. Objects at rest do not move because all forces acting on them are balanced. If forces become unbalanced, so if one force is greater than another, then an object can gain motion. So when something is sitting still on a table, it doesn't have any motion because the force that it exerts on the table is equal to the force that the table exerts on it. So by balancing out those forces, then that thing doesn't move. What would happen to make the object move upwards? So if we're looking at this object on the table, basically to move it upward, we're going to have to put force underneath of it, right? And what would happen to make the object move downwards? Well, there'd have to be a greater force, obviously coming from the top, pushing down on that. Force is defined as a push or pull on an object. An object has many forces acting upon it, and the sum of these forces is referred to as the net force. When a vehicle is braking, for example, there are 3 different forces that act in the same direction, causing the vehicle to slow down. So the force of air resistance, so that's like basically what you would feel like if you put your hand out the window when you're driving in a car. There's some like resistance there due to the air currents. The force of friction, so that's basically the tires on the ground. Basically they are, I guess, exerting or losing some of their energy through friction, so it's giving it off as heat. And then the force applied by the brakes, so the brakes are putting a force which will, I guess, stop the wheels from turning. If these 3 forces overcome the force that is propelling the vehicle forward, then the vehicle's net force will be negative, causing it to decelerate and eventually come to a stop. So because that force on the brakes is at a higher, I guess, force than the other ones, that is why it can come to a stop. How does mass affect that? Well, it says another factor that can influence the rate of acceleration or deceleration of an object is the mass of that object. Objects with a greater mass have more difficult time overcoming opposing forces. Heavier objects thus experience a decreased rate of acceleration when a force is applied. So basically what it's saying is that it's harder to speed up a heavy thing, just like it's harder to slow down a heavy thing. The heavier something is, the greater force that you're going to have to put into it to basically stop or to start it. And you might notice this when you're driving like a truck, for instance, where, but you don't drive. But when I notice this when I drive my truck versus my SUV, you have to put a lot more gas into it just because the truck is bigger, it's heavier, you're gonna have to put more force to move it forward. And the same goes for when you're stopping. A small car, really easy to stop. You just zoom away, stop really fast. Well, it takes a lot more to stop a bigger vehicle, so you're gonna have to put more time into it. So Newton's second law of motion is exemplified in this formula. And the formula is acceleration is equal to F net, which is our net force, divided by our mass. It says the relationship between net force, mass, and acceleration is described by Newton's second law of motion, which states that an object will accelerate in the direction of the net force acting upon it, and the object's rate of acceleration is inversely related to its mass. So note that the force is measured in newtons. So this is really important when we're doing these types of questions, is that we're keeping this newtons. Newtons is our units, And that is equivalent to this, which is kilograms times meters per second squared. Okay? So these two equal the same thing. And so sometimes you might see kilograms times meters per second squared, and other times you might see just N. Well, they mean the same thing. Okay? So now we can try some of these examples. Just gonna take this example and put it into the notes if I can. Maybe I can't.